So today we are going to basically look at the binomial distribution and basically some of the conditions or to what we call the properties of a binomial distribution. So could you briefly read through the first those properties?
Binomial theorem describes
Are you able to see the screen?
yeah, but the letters are quite small.
Okay. Okay, let me read. So we are saying the binomial distribution describes the behavior of a random variable, say x. So we use x to represent our random variable, and it has the following properties. So in the binomial distribution, or when we perform a binomial experiment, there is a number of repeated trials. So we have a number of repeated trials, and that is abbreviated as n. Then trials have only two possible outcomes. So we can either expect a success or a failure. For example, in tossing a coin, if our interest is to obtain a head, so when we toss and obtain a head, that would be a success. But if we toss and obtain a tail, then that would be regarded as a failure. Then next one, each trial is independent of the other. So there is dependence, there is independence of the events of the trials. So if I toss a coin and obtain a head, then it doesn't mean that on my next throw that the outcome I get will be dependent of the first one. So they are independent. Then the probability of success, which we normally abbreviate as P, is constant throughout. So the probability of success is constant. Then what is not included here, when we add probability of success and probability of failure, that would be able to give us a what? A 1. Because we all know that total probability gives us 1. Then here on this image, they're trying to bring out the binomial distribution. So they are beginning with the word by, which in this case means a 2. Okay?
Yes.
So they're saying the binomial distribution, there are only two possible outcomes, a success or a failure. So that is why we regard it as a binomial distribution. Then in here, we have that a binomial distribution. So I'm saying x is approximately binomially distributed with n and p. So I said n is the number of repeated trials, and p is the probability of success. Yes. Then the facts here are still the same, like the properties, that there is a fixed number of trials, which is n. Each trial has only two possible outcomes. That one we have explained. The probability of success is constant for each trial, then trials are independent. So basically that. Yeah, so the rest you come and read through. Let me also share something else here, then we go through it since you had covered some part of it. So we have talked about the properties of binomial experiment. Okay, so those ones we have talked about them. That where we said probability of failure, Q is equal to 1 minus P because of the law of total probability. That when we add total probability, it gives us
1.
A 1. Then we also need to, there is a binomial formula that we use to calculate, which I think you are aware of. So can you read it or tell it to me? Because you said you had covered something about them. So with the binomial formula, we are saying if X is binomially distributed with any number of trials, which we abbreviate as X approximately B bracket NP. So N is the number of trials and P is the probability of success. Then we are able to have this formula, that's probability of X capital equaling the small x the probability of X equaling to small x is equal to N combination X, P to power X, then Q to power N minus X. So in here, still N is the number, X is the number of successes that are obtained. We have seen the P, the Q, and the N. So N is the number of trials, P is the probability of success, and then Q is the probability of failure. Then we can look at the expectation stroke the mean. So major here we are looking at the average, what the expected value of X in this binomial distribution. So the expected value of X, what we call the mean, is given by the formula E of X, so it is abbreviated as E of X. So the mean is abbreviated by E of X, and it is equal to NP. So the n as well is the number of trials and p is the probability of success. So the mean is as simple as that. So we just get the number of trials and then we multiply by the probability of success. Any question?
So the part of the formula, I've missed it. I've missed that part.
So the formula we are saying, the formula here, we have probability of x equaling the small x is equal to n combination x. So this one, once you meet it in paper 2, it means n combination x, and that is on your calculator, or you can define it by using the paper pure math knowledge. And then the p is the probability of success, so it is n combination x, p to power x, then q to power n minus x. So all these variables are known except the x, which x we are saying is the number of successes.
Number of successes.
Yes, that are obtained. So that is simply how we find the mean, the probability of x equaling to small x for a binomial distribution. Yes.
Okay, sir.
Then from there we can go to the mean. So the mean, what we call expectation, is given by the formula. So the mean is denoted by E of x. So the EX and that is simply when we get the n and multiply it by probability success. Then we can look at variance as well. So the variance is obtained by getting n times p times q. So that gives us the variance of x. And only that for a binomial distribution. Yes. And if we want to get the standard deviation, we just get the positive square root of variance. Is that okay?
Okay.
So we are going to begin with this example here. So we are saying an unbiased die is tossed 9 times. Find the probability of obtaining 2 6s, and then the probability of obtaining at least 2 6s.
2 6s.
From this example, what is n, what is p, what is q?
It's just n is 9.
N is 9. Okay, let me get right here. Yes, n is 9.
Then p, I think, is 2.
P is 2. Probability of success. The 2 is the x. Because x we said is the number of successes that are all obtained.
Yes.
Then we are going to get p. So p, which is the probability of success. So what would be the probability of getting a 6 when we are rolling a die, or when we are tossing it?
So we use this formula that we have probability of x equal to x is equal to n combination x.
Not yet. We need to first come up with the probability of getting a 6. Okay, when we are rolling a die, what would be our sample space?
Sample space is 6. 1, 2, 3, 4, 5, 6.
So then what is the probability of getting a 6?
It's 1 out of 6.
1 out of 6. And now since we are in a binomial, this would be equal to P, which is the probability of success, because we are interested in getting a what? A 6.
A 6.
Yes, then after that, we are going to, so now after getting a 6, a P, so also use the formula P plus Q is equal to?
Is equal to 1.
So meaning the Q will be 1 minus P, but the P is 1 over?
1 over 6.
What's going to be a Q?
Minus 5 over 6.
5 over 6. So then we come and substitute here in our formula. So probability of x equaling to 2, because we need at least, we need the what? The 2 6's is equal to, our n is, when we substitute in the formula, n combination x, so it will be 9 combination 2. Then we multiply by P, which is 1 over 6 to power 2. And then 5 over 6 power 9 minus 2. This should be a 2. Yes, so that would give us 9 combination 2 times 1 over 6 squared times 5 over 6 to power 7. So when we get to this step, in paper 2, we are advised to input that in a calculator, and we generate the final answer. So do you have a calculator with you there?
No.
Sure.
Yes, I'm sure.
Look for it. Okay, so when we calculate, we shall get our probability as probability of x equaling to as 0.2791. 0.2791.
91.
When we put those values in what? In a calculator. Then we can go to our second example. Probability of obtaining at least 2 6's. So which values would best suit this at least 2 6's? Which values of x shall we consider? Yes, Kellen, welcome.
Oh.
Yes, at
So
least. We are going.
At least we are going to start from 2, 3, 4, 5, and 6.
And only 6. According to our question, our n is 9. Okay, we are tossing this die 9 times.
Oh, 9
this
times.
Should go up to what?
Yes.
To 9.
Up to 9.
So meaning if we are to find this, we would need to find probability of x equaling to 2 3, 4, up to 9. Is that clear?
Yeah.
And if it happens that you are in an exam, would it be the best method to use?
No.
No. And if it
Very
is not,
lengthy.
okay, then we reverse it.
Yes.
And use this, that when we get probability of x greater or equal to 2 plus probability of x less than 2, then that gives us
1.
it gives us a 1. I hope this statement is clear. Because for probability of x greater or equal to 2, we saw that we are going to get probability of x beginning from 2 up to 9. Is that okay?
Yes.
Then we also have numbers which are less than what? Which are less than?
Less than 2.
So which would be probability x equaling to 1 and what? And 0.
0.
Yes, when we add these two probabilities here, they should give us a what?
A 1.
A 1. So that is why I'm saying that probability of x greater or equal to 2 plus probability of x less or equal to 2 should be able to give me a 1.
A 1.
Such that now I transfer this to the right hand side, and then I'm able to do this probability without going through a much more problem. Okay, like I take a little time to do it rather than doing finding probability of x equaling to 2, x equaling to 3, x equaling to 4, x equaling to 5 until I get to 9, which would be time, a time consuming. Then when we get here, we are going to get probability of x less than 2. So probability of x less than 2 would be probability of x equaling to 1 plus probability of x equaling to 0. So this one here we can easily do
0.
by substituting in the what? In the formula. So when x is probability of x equaling to 1, so we shall have 9 combination 1 times 1 over 6 to power 1 times 5 over 6 to power 9 minus 1. So which would give us what? An 8. Okay. I guess this one has some errors. Would need. Karen, do you have a calculator? Then
Yes.
probability of x equaling to 0 would be 9 combination 0, 1 over 6 to power 0, then 5 over 6 to power 9. So this one here was a type of error. Okay. So this would give us, first check whether 9 combination 2 times 1 over 6, I think this one would automatically be a 1, times 5 over 6 to power 9, whether it gives us 0.1938. So we can first check for 9 combination 2 times 1 over 6 to power 0, then times 5 over 6 to power 9.
I don't know how to put the correlation thing in the calculator.
The combination.
Correlation thing.
You place a shift and the division sign, I think. So on the division sign, are you able to see there like n combination R?
Yes.
Yes, so you first place 9,
Yes.
and then place shift and the division sign,
Yes.
and then a 2. So which answer has it given you?
Nine division sign. I pressed a 2 or 0.
2. 9 combination 2. 9 combination
I've got
0, 0. Yes, it should be a 0. I think that one as well isn't it a 1? 9 combination 0.
let me check.
Yes.
I'm getting 9.
Yes, it is 9.
Okay, let me finish up. I've got 2.5117.
Sure.
Yes.
So you said 9 combination 0 was 9.
Yes.
Okay. Let me try that. Let me try as well to calculate. Now you do like this, get 5 divided by 6 to power 9. Which
Five.
answer? 5 out of 6 to power 9.
Yes.
Equal signs, like you get the answer for it.
Yes.
Then multiply it by 9.
1.7445.
Sure.
1.7443.
Because the value should not be greater than 1, because it's a probability value. 5 over 6 to power 9.
5 out of 6. 5 out of 6. Nine. Nine correlation 0 is 1.
It is 1.
Yes, that was
Okay.
the mistake.
Okay.
1 times 5 out of 6 to the power 9. The answer is 0.1938.
0.1938.
38.
Let me check whether it was the one that I had. Okay, it was the one. So this is giving us 0.19 because here it was a mistake. So this would be a 0, this should be a 0, this should be a 9. So now we get 0.3489 plus 0.1938, and then we get 1 minus the answer. Emily, is everything okay?
Yes, teacher.
Yeah, that is good.
0.4573.
0.4573.
4573.
Okay, that is great. Then our next question, we were asked to find the mean, and the mean we just get n times what? N times p, and our n was 9, and then the probability of success was 1/6. So that is going to give us 9 divided by 6. And then for variance we get NPQ, and that will be 9 times 1/6 times 5/6. So when you calculate, what do you get?
9 times 9 times 1.25.
1.25.
Yes.
Okay, so this one I left it as 45 divided by 36, and it is the same value. So after that question, so we can
Excuse me, sir. So while calculating these numbers of probability, is it allowed to reduce, or the numbers are supposed to remain the way they are?
like if they have a common factor?
Yes, like 9/6. Can't we reduce?
Yes, we can reduce it. It's okay. This we can reduce it by 3. It gives us 3, and here it gives us a what? A 2.
Yeah, too.
Yeah, so we could have it as 3 divided by 2.
Yeah, too.
Yes. I guess it's okay then.
Yes, sir.
Okay, so let us do this second example here. So we are saying in a large batch of plastic moldings, 25% have faults. If a random sample of 8 moldings is inspected, find the probability that a sample contains 3 faulty moldings and not more than 2 faulty moldings. So let me give you 30 seconds to get for me the n, the probability of success, which is p, and then the probability of failure, which is q. I'm waiting for your answers.
And a large batch of 20. A quarter is for failure, then 3/4 is for P.
A quarter is for failure,
Then 3/4 is for success.
for success. Okay, thank you. Emily? Okay, so Karen, I think you have reversed the question because you saw this as the forte, okay, and then you regarded it as a failure. No, for us now, our interest is to get those that are forte, so that is our success. Okay.
Yes.
So 25% have faults. So the probability of success P is going to be 1 over what? 1 over 4, because that is our interest.
Yes.
Yes. Then now the Q becomes 3 over 4. Is that right?
Yes.
Then what is our N?
Eight.
Our N is 8. Thank you. Emily, are we at par?
Yes, sir. I had stepped away a bit. I've not got the question.
We were just interpreting this question here that is displayed as we are getting the P, the success, and then the Q, and then the N.
Okay.
So our first part is to get 340. So this was the interpretation. N is 8, P is 25 over 100, which we can say is 1 of 4. Then we can write it as 0.25. Then Q would be 1 minus 0.25, which gives us 0.75. So we are going to begin 340. So we shall have probability of X equaling to what? X equaling to a 3. Then we substitute in the formula, which is P, probability of X equaling to a small x. And this is N combination X, P to power X, then Q to power N minus X. So that is what we have done here. So 8 combination 3, 0.25, which is the probability of success to power 3, which is our X. Then 0.75 to power N minus X, which is 8 minus 3. So that would give us N combination 3 times 0.25 to power 3 times 0.75 to power 5. Karen, you can help us have that input in a calculator.
Zero point 2076.
0.2076. Okay, who can interpret for us the second part, not more than 2? four term wordings.
Means
So,
2 and below.
Means 2 and below, not more than. Okay, thank you. So that would mean probability of x being less or equal to 2. Then what are numbers that are less or equal to 2? Which numbers are less or equal to 2?
0, 1, 2,
Okay, 0, 1, and
and
2.
2.
So here we shall have this would be the same as probability of x equaling to 0 plus probability of x equaling to 1, then plus probability of x equaling to a 2. So that is that. So we shall have this is for x equaling to 2, 8 combination 2, 0.25 to power 2 times 0.75 to power 8 minus 2. Then for probability of x equaling to 1, we shall have 8 combination 1, 0.25 to power 1, 0.75 to power 8 minus 1. Then for 8 x equaling to 0, we shall have 8 combination 0, 0.25 to power 0, then 0.75 to power 8 minus 0. And when we input those in a calculator, we should be able to get that. Emily, you could check for us one of them, such that we are sure that our answers are correct. No, Karen.
Deviation 2. The first one is 0.31146.
Okay.
Then the second, one is 0.26696.
Okay. So
97. 0.26697.
okay, you could now add this. That one we have confirmed.
Zero point 67852.
0.68.
0.67853.
So if rounded off, it could as well bring us to that answer. So that would be probability of x being less or equal to 2. Are there any questions to the work we have covered?
So the other second formula that you gave us, we only use it if like the numbers are very many.
Yes, if the numbers are very many.
What if there's few and you want to use it?
What if they are?
There are few and you still want to use it?
And when there are few, like for in case this, so this, if you use it would give you now the many that you are avoiding. Okay.
Yes.
But next week we shall see an alternative one where we use tables. Okay. Which is
Yes.
which is even more simpler and more time saving. Yes. So I request the video to scan for us the binomial table. So I he will post it. He will post it on the group as soon as possible, such that we are able to use it next week.